All right, class, let's work through 12-1 homework, estimating limits graphically. Hopefully the first couple of problems, pretty straightforward for you. You can punch these into your calculator. You can graph them manually, but just remember this is the limit of 4x minus 10 as x approaches 5. And hopefully at this point you recognize this as a line, y equals 4x minus 10. Negative 10 is the y-intercept. Your slope is 4 over 1. And so as x approaches 5, what happens to the y-axis up here? And I've circled this not because it's exclusive necessarily, just to kind of highlight it. But you can create a table. You can punch this into your calculator. Just go to your y equals function, type in 4x minus 10 and graph. And then you can check your table. Don't forget, I mentioned this in the previous video, to go into table set and check and to change the interval to 0.001. This will give you some better intervals here, but it will probably give you 4.998 instead. So, but that's okay. It's still going to show you the same data. So as we approach 5 from the left here and from the right, what we see is that it's approaching 10. So the answer to this one is x approaches 5, f of x approaches 10. Same thing for 3. You can graph this manually. I'm not sure why you'd want to do that. I would just punch that into your calculator. And we're looking for what happens as x approaches negative 2. And our table confirms this. Now, I took this straight from the calculator. And so you see what happens. My interval is set up at 0.001. And it's such a tight interval that it gives me negative 15 for every f of x. But that's still okay. Because that's my answer here. We can see that, yeah, as we get closer and closer to negative 2, it does in fact approach negative 15. All right, so negative 2 is going to be right in here. This is negative 1, negative 16. So as you begin to go up towards negative 2, you're approaching negative 15. All right, let's look at 11. The limit of sine x minus x over x as x approaches 0 from the right. Go ahead and separate this out. If you really factor out an x here and you end up getting sine of x over x minus x over x, you're really not factoring out x. You're just separating this into individual fractions. The 1 is x over x, so that's going to be 1. So then you can focus just on this on your graph. If you look at a graph of this, it is going to be a sine wave, but it's actually going to cross when it's 0 is x. The sine, the y of x, excuse me, the f of x is going to be at 1, but we know that it can't equal 1 per se, but it's approaching 1. So to write it correctly would be as x approaches 0 from the right, f of x is approaching 1. So in that sense, we can think of, we know this case it's going to be 1, 1 minus 1 equals 0. All right, so 13, the limit of 2x squared over the absolute value of x as x approaches 0. Well, here's the graph of this function. So regardless of what direction you approach, as you approach 0, f of x also approaches 0. The limit of x squared minus 5x plus 6 over x minus 3, we're wanting to know what happens as it approaches 3 from the left. In this case, you can go ahead and reduce this into product of binomials, cancel out the x minus 3, and you're left just with x minus 2. That's a lot easier to graph. And we want to know what happens as it approaches 3 from the left. Well, when you graph that and look at it, f of x is going to approach 1. So there's your answer, 1. 17. Now on this one, you can see I wanted to start working, and I'm going to break this down into the product of binomials. But this absolute value, I have to be careful here. We're not going to be able to straight cancel this. So I wanted to show you that this is an easy mistake to make. And all of a sudden we get here and we're just going to draw a line at the positive 3, and we're going to have this line here, and it's going to go infinitely in both directions. But that's not true. We're dealing with just the absolute value of x plus 2. So if you graph this, and encourage you to graph this expression in your calculator, and you'll see it. It'll plot like this, and then all of a sudden you see that x approaching negative 2 from left and from right, they approach it differently. All right, they're going to approach and they're going to come up with a different answer as you get to x equals negative 2. They both approach different things. This one's going to approach negative 1, and this one's going to approach positive 1. Therefore, we must say that the limit does not exist. Moving on to 29. believe on this one they gave you a couple of graphs to look at. I did not plot those graphs here, but you can see them. And here you just want to say, okay, what happens as x approaches -6? And as you work to -6 on the graph, you'll see the f of x is going to approach 4. As you approach a +4, what happens to f of x? It approaches -6. Last two problems, 33. Best thing to do is to graph this in your calculator, and you will see a graph that looks remotely like this. Well, what happens as x approaches -4? All right, that's going to, and I didn't graduate this graph, but if you look at it in your calculator, you're going to be going out this way as x approaches -4. So what's happening? Your f of x is moving towards -infinity. It just keeps on going out this way. All right, scratch that. I have no idea what I was just talking about, but you can all just, silently laugh at me. But just maybe I'm going too quick. But think about this. We're dealing with the f of x, and so we're doing up and down, right? As regardless of, and I should have graduated this, you could see it, but either way, whether I approach -4 this way or this way, where am I going? Down, because I'm dealing with f of x, right? I'm dealing with this y-axis, so as I am going down towards -infinity. There we go. Hopefully that made more sense. Apologize for the little crazy train that I followed there for a moment. Now on 35, we have the limit of the absolute value of x divided by x minus 4 as x approaches 4. Well, that's going to give us division by 0 in the bottom. If you look at your graph, it looks like this. Well, here's our asymptote here. And so this limit is not going to exist. Guys, I hope that helped with 12-1. It's a pretty quick review of limits. We'll post the 12-2 video shortly.